Okay guys, this is the next video for solving a system of equations by using the elimination method. And here we have the graph that's up, and it's just to kind of refresh our memory of what we are actually finding when we use the elimination method. And if you guys can see here, I've got number one already programmed in, and if we graph line 1, x minus 4y equals negative 17, this is what it looks like right here. Okay, and then if I graph the second line, boom, here's that blue line, the second line, and this is our intersection point right here, 7, 6. Now, if we were just given this without the graph, we would have to, find the points, plug them in, make a table, find the, and graph it by hand. And sometimes that could be a very tedious process to find just the intersection point between these two lines. So instead we use the algebraic method, the elimination method, to find the intersection points. All right, and so we're going to go over number one and number two. And actually in this video, we're just doing number one. Okay, so today we're going to do the elimination method. But before I go into number one and number two, I want to refresh our memories about something here. So if we have 3x and then 3x underneath here, one has to be positive and the other has to be negative in order for them to eliminate. The numbers are the same, 3 and 3, but the signs are different. All right, because that 3 minus 3x equals 0x. And I have to apologize, that looks really bad. So this is really important, that we want to make sure that the numbers are the same but the signs are different. So if I have a 6y here, and if it's a negative 6y, I want to ask myself, what do I need underneath to eliminate? And that would be a positive 6y. Alright, negative 6y plus 6y equals 0y. So then it would be eliminated. So it's going to be very important that we come to this conclusion, this understanding of the numbers have to be the same, 6, but the signs are different. Okay, negative, positive. All right, and now we're going to go into, let's go into number one right away. Okay, and that's x minus 4y equals, let's see, negative 17. And then we have negative 10x plus 12y equals 2. And so now we want to find numbers that are the same, but signs are different. So the coefficient here is 1, and then it's negative 10, and then we have negative 4, and positive 12. So we don't have any numbers that are the same like we did in our previous assignment. So we are going to have to somehow make them the same. And so we look at 1 and 10. We could choose to eliminate the x's. And I just know from experience, going from 1 to 10, that's a big jump. So it might be more tedious to go about changing the x's. But if I look at the y's, 4 easily goes into 12 3 times. And the signs are already different. So I'm going to choose, because I just know that this is going to end up being the easiest one. Once you get better at this, you'll be able to more easily recognize which ones are better. Actually, let me undo that before I go forward. Okay. So since we're choosing to eliminate the y's, I've already got a positive 12y here. Alright, I've got that positive 12y. And to eliminate, that means I need to have a negative 12y here. But I've got that negative 4. So I got to ask myself, what can I do to that 4? that negative 4, so that I can get a negative 12. And the answer is to multiply by a positive 3. All right, and you're not just multiplying the 4y by 3, you're also multiplying the 3 times 1x and the 3 times the negative 17 as well. All right, so 3 times that 1x is a 3x. All right, and it changes. So we have 3x here, and then I'm going to also make this blue as well. Sorry guys, this is so sloppy. Negative 12y, and then negative 17 times a positive 3 gives me a negative 51. So my my top equation has changed. All right, because I multiply by 3 here to get that negative 12y. All right, and I have not made any changes to the bottom, so I am just going to copy down the bottom equation. Okay, and then I've got that negative 12y plus 12y. It's eliminated. Then I have 3x. Now this is a positive here. When there's no sign, it means it's positive. Positive 3x minus 10x, that gives me a negative 7x equals. And then negative 51 plus 2 gives me a negative 49. And then I just solve this equation. I'm going to divide by 7, divide by negative 7, excuse me, and x equals a positive 7. Okay? So now I found my x, and now I'm going to choose to find my y. And again, I'm just going to do a little bit of mental math before I start doing the work. I'm substituting in for x. So if I plug it into the bottom equation, I'm going to start dealing with really large numbers. Negative 10 times 7 is a negative 70. And then I still need to do some math to find the y. That makes me a little uncomfortable. I'm way more comfortable dealing with just 1 times that x. So let's go ahead and do that. Let's use that that top equation instead. So it's x minus 4y equals negative 17. So instead of x, I'm going to put that 7. So it's 7 that I'm getting from over here minus 4y equals negative 17. Alright, now I'm just solving for y like I did before. Subtract 7 from both sides. I'm left with negative 4y equals negative 24. And I divide both sides by negative 4. And y equals positive 6. So it intersects, so I have an intersection point here. Point at x7, comma 6. And Charlie found a mistake on my last video, so props to Charlie for finding a mistake. Make sure you list that x first as 7 and then the y next. Alright? So that's number 1, guys.